Hey everybody, it's Hutch here, and we're on module 11 now, geometric figures. You can take a look at what you're going to be learning, a whole bunch of different geometry concepts, and then check out all that vocabulary. Some new things that you haven't heard of, like transversals, but some familiar things as well. I mean, you know what congruent means, and pyramid, and cylinders, and things like that. But we'll be exploring some new stuff along with that. So on to 11-1, this is vertical and adjacent angles, okay? And I'll explain what that means as we continue, okay? So if you think about a clock, okay, it says the hands of a clock form an angle with a vertex at the center. Vertex, the for dummies version of that word might be a corner, but the technical term would be a vertex, where the two line segments or rays meet. So at different times of the day, the angle of clocks form different acute or obtuse, acute, right, straight, or zero angles. And they're asking you to draw each hands. So just reviewing, an obtuse is anything greater than 90. So we know the vertex would be the point in the center. And we obviously know that this makes a 90-degree angle, so greater than 90 would be anything bigger. And let's go ahead and do the arc to show that obtuse. Okay. Now, it has to be less than 80 because 180 is what's called a straight angle. So let's go ahead and do acute. And remember, the trick is a cute little angle. And so that's less than 90 degrees. So we can have it go straight down, maybe going up this way, and let's go ahead and show that arc there. A right angle we know is 90 degrees, so let's go ahead and represent that. We represent that with a box. Okay, straight is exactly 180, so that's going to be straight through the point and all the way around. Okay, so I'll show the arc like that. And then a zero means that the ray is actually overlapping the other ray. And so it's there, you just don't see it. So it would sort of like be like me representing it like that with two colors. Okay. All right, so let's go ahead and continue. We're going to talk about these symbols. The symbol for angle is this. Okay. Notice it's a straight line on the bottom and then an angled line segment going up. So an angle can be named in a lot of different ways. Let's go ahead and just jump in and explore this. So you can see that an angle can be named in 4 different ways for this particular image. One of the big things to be aware of, though, is when we say angle, RST, the S is the actual like angle vertex itself. So if you look at this one, like this would be the vertex itself. So you could say TSR or RST, as long as the S is where that specific angle is. Okay. And so you can see we have angle RST, and so that forms the angle. You could just say angle S. We could say angle 3, or you can go the opposite and start with the T and say angle TSR. Okay, so any of those options can be used. Let's go ahead and take a look at example 1. Name the angles in 4 ways. So let's find all the correct names for the given angles. Go ahead and pause and see what you can find, and we'll take a look together. All right, so let's see. We have angle 1, so we could just say that, right? We could also just say angle Y. So let's find that. There we go. Let's also look at it by naming the entire angle using the rays and the vertex. So we could start with this outside X and say X, Y, Z. Okay. And we can see that angle XYZ is, where is that? Right here. Okay. And then we could do the opposite and do ZYX. So let's find that. And there we are right there. Okay. Those other ones don't work because you wouldn't do Z then X. The line's not going that way. Okay. All right. So we can name it by the vertex, the 3 points on the angle, or if they give a number on the interior of the angle. If you haven't heard the word interior, in means in, and X means out, like exhaling. So we have interior and exterior. So let's go ahead and try it out. Pause and see if you can name the angle in 4 ways. If you need reminded about how to write them, take a look up there. All right, so you should have, we could name it by the number by just saying angle 2. We could say angle B, okay? Or we can use the 3 points and we can say angle A, B, C. Or angle, we can go backwards, C, B, A. But just notice that the middle of the middle letter is our actual angle. Okay. All right, let's go down to the next one, which is vertical angles. So here's what I want you to do. I actually want you to write this, okay, a V and an A. You can do a little line there. Okay, so this says vertical angle. Okay, and so this is your little hint, and I want you to go ahead and write that exactly. And I also want you to put a little spot here and a little spot there. Okay, because these 2 spots, when you have a vertical angle, these 2 spots are congruent. Okay, remember congruent means equal. Okay, and so it means that angle A and angle B are congruent with each other. Okay, so if you look at any of these angles, okay, let's go ahead and just highlight a couple vertical angles. Anytime you see, do you see the same shape that I drew? The V and the A? Okay, the thing is though, I want you to notice that they cross like this. It's not one going like this and then changing a weird angle. It has to be that perfect X for them to count as vertical, okay? And so it's the opposite angles. And so we have angle 1 and angle 3, and let's pick a different color. And we have angle 2 and 4. Those are the equal ones, okay? All right, let's go ahead and try it out here. Okay, so example 2, identify the vertical angles. And so my tip to you, so you don't get lost, is like grab a highlighter and make the X. So if I make the X like this, it allows you to see which ones fit in that X. So we have 6 and 3, okay, are vertical. But notice that this here, okay, 1 isn't part of my X, okay? It's the 1 and the 2 that are part of this particular X. So that means 1 and 2 combined are the same as 5 and 4 combined. Those are on the opposite sides of my X. So I just want you to see that when I say highlight your X to help you out, I really, really mean it. It's very, very important for understanding what's going on. And then you could highlight other X's too. So I can highlight this one and this one, and then I can look which ones are opposites. So 2 and 5 would be equivalent, okay? But if you look here, 6 and 3 aren't part of my X, okay? This X is here and here, okay? So what are actually equal to each other? Well, the 6 and the 1 are equivalent to the 4 plus the 3. Okay, those together are equivalent. So again, I just want you to see another example of those. Okay, so let's go ahead and take a look. It says angle 1 is vertical to what? Okay, so again, you want to look at the X for angle 1. And then we can see, okay, angle 1 is vertical with which one? Okay, it's straight across to this one. And so we would say angle 4. Okay, let's look at the next one. It says angle 2 is vertical to what? Okay, so I look at my X here. Angle 2 is vertical. What's straight across? To angle 5. And then angle 3, if I clear this out, here's angle 3. So I'm going to make the X around the angle 3. Angle 3, what's opposite of it? If you said angle 6, you're good. Okay. All right, let's go ahead and take a look at the check and try it out on your own. So hit pause, see how you do. All right, so if we, again, we're looking at angle 1, so I'm going to draw the X right around 1 to help me see straight across. There we go. Angle 4. Angle 2 goes with angle 5. And angle 3 goes with angle 6, is vertical to angle 6. Okay. So again, you can use those tips of drawing the X's to help you out if you don't see it easily. All right, so let's go ahead and kick it up a notch. We're going to use those vertical angles, okay, to help actually solve for X because we know things are true about vertical angles. So they're telling us angle AEB, which is right here, okay, AEB, and angle CED are vertical angles. Okay, and what do we know about vertical angles? They're equal to each other. So you can actually on the side make an equation, say, well, 75 is equal to 4x minus 5. And you don't need parentheses, they're just organizing those numbers together, okay? To say that that combo of 4x minus 5 is the angle. So now you can do what you normally would do. Separate your workspace and follow your SAD-MERG. Okay, opposite order of operations to solve for the variable. So you can see why your midterms and things like that are so important because look, we're continuing to use this knowledge to solve things. Okay, and then we need to go ahead and isolate the variable, divide both sides by 4 to get x by itself. And we have x equals 80 divided by 4. Let's grab our Desmos calculator or whatever calculator you're going to use. And we have 80 divided by 4, and you can see is 20. Okay, and even if you knew that, it's always good to double check and make sure you don't make a mistake. So what is x? X is 20. Now understand, x isn't 20 degrees. X is just the number 20. Okay, so we figured out what x is, and take a look. If you plug that in, 20 times 4 would be 80. And 80 minus 5 is 75. So that is correct. 75 equals 75. Okay. And there we go. All right, let's go ahead and move down here. It says, so the value of x is, and we said 20. Okay. All right. Example 3, using vertical angles to find missing values. Now, I got to say, I love these. It's like a puzzle to me. And when you understand rules about geometry and these different lines that are vertical angles or complementary or supplementary, it's just really, really fun to solve them. Definitely very puzzle-like. All right, so let's go ahead and solve, and we're just trying to find x. We know that this is 130 because it's a vertical angle with this one, which is 130. Okay, so we can go ahead and create our equation. So we can say, well, 130 equals 2x plus 2. And then we can go ahead and solve our equation. So let's just rewrite it here. And go ahead and separate your workspace. And away we go. So subtract 2 both sides. We're doing opposite order of operations. We have 128 equals 2x. And then isolate your variable, divide both sides by 2. Cross that out, and what do you have as your answer? What does x equal? X equals 128 divided by 2. Let's go ahead and plug it in just to be safe, is 64. Okay, so if you did 64 times 2 plus 2, it would equal 130. Always not a bad idea to just check. Okay, 128 plus 2, yep, we're good. Okay, so there we go. Let's go ahead and try it out here. Pause and see how you do. Okay. All right, let's see what you did. So step 1, write our equation. So we know that 2x plus 6 has to be equal to 80 because if I draw my x here, these are vertical angles and they're equal to each other. Separate our workspace, subtract 6 on both sides, cross that out, and we have 2x equals 74. Okay, and then we're going to go ahead and divide both sides by 2 to get the variable by itself. And we have 74 divided by 2, and that is 37. Okay, and if you check, we have 37 times 2 is 74, plus 6 is 80, and 80 equals 80, so we're good. Okay, all right, now we're going to go ahead and take a look at the word adjacent. So here's a new vocabulary word. If something is adjacent, it means it is next to. So let's go ahead and write that so you remember. Okay, next to is what that means. And so they share a vertex, but they don't overlap. Okay, so there can't be any gaps or spaces. They are the ones that are right next to the other one. So let's find the adjacent angles. So the number 1, so we could say angle 1 is next to what, or adjacent to. We can say angle 1 is next to angle 2, right? They're right next to each other. But angle 1 is also next to angle 4, right? Okay, right there. So we took care of angle 1. Let's go ahead and take care of angle 2 now. Okay, so I'm going to move over. So what's adjacent to 2? Well, we already said 2 and 1 are adjacent. So turns out that angle 2 and angle 3 are adjacent. Okay, now we've got all the 2's. Let's go ahead and take care of 3. So what's adjacent to 3? Well, 2 is, but we already got 2 and 3. Okay, and so the one that we're missing is angle 3 with angle 4. Okay, and we already got 1 and 4, so we're done. So those are 4 pairs of adjacent angles. Just remember that adjacent is next to. So go ahead and take a look at this. Which angles are adjacent to angle 2? So here's angle 2. So what do we have adjacent? We have angle 1 is next to it. And which one? Angle 3 is next to it. Okay, or adjacent. What angles are adjacent to 5? We have angle 6 is adjacent to 5, right next to it, and we also have angle 4. And there we go. So not bad. Once you learn the words, like I said, I think these are pretty fun. All right. So because you understand the rules of adjacent, it helps you understand some other information when we start adding different degrees and things like that. So let's see. It says name the angles that are adjacent to angle 1. Because angle 1 shares a common side and vertex with 2, they are adjacent. What else is adjacent to 1? Well, we can see right next to 1 is angle 6. Okay. All right, let's go ahead and check all the angles that are adjacent to angle 3. Okay, how many can there be? There can only be 2, right? Because there's only 2 sides next to the 3. So if you said angle 2 and angle 4, you're right. Let's move on. Okay. All right, so let's use adjacent angles to find missing values. Okay, and this is where we start having to understand some other things. Okay, so when we have a straight line, how many degrees did we say is a straight line? It's this distance from here all the way to here. Okay, and it's telling you that angle AEB plus angle MEB equals 180. So 180 is a straight angle. So we're saying this whole thing is 180 degrees. So if you know that, then we can create an equation, right? So let's go ahead and create that down here. So we know that 5x plus 115x, what does that have to equal? Well, the whole thing has to equal 180 degrees because those 2 adjacent angles create a straight line. And so once you know that, then you can go ahead and solve for x. Again, another little puzzle. So let's go ahead and solve this. Okay, we're left with 5x equals 180 minus 115, 180 minus 115, and we have 65. And then go ahead and isolate your variable. So instead of times 5, we're dividing both sides by 5. You can see my organization, still maintaining that. And x equals, should know 65 divided by 5, but we're just calculating everything anyway, is 13. Okay, maybe you wouldn't know that one. All right, so the value of x is 13. Okay, and so if you plugged in 13 for x, okay, see what you would get. We would do 5 times 13. Okay, because I'm plugging in 13 for x. And that gets you 65. And then plus 115. And you can see 180 equals 180. So that checks out. Okay. All right, let's take a look at example 5. We're going to continue using that understanding of the adjacent angles. to help us solve for x. So we'd be wondering, what is the degrees of this whole thing? Because we know 5x plus 63 would equal this whole thing. Well, let's look at what information they're telling us. They're telling us that angle ABD. So where is that? Starts here, ABD. All right, that whole angle they're telling us is 128 degrees. So look at the notes I make to help give me clarity. So I have 5x, and you could do 63 plus 5x, it doesn't matter, plus 63 equals 128. Those two angles equal the big angle. All right, let's go ahead and solve for x, just like we normally would do with solving equations. Okay, I love how connected everything is from all our past learning. So minus 63 to both sides. We're left with 5x equals whatever 128 minus 63 is, which is 65. And then let's go ahead and divide both sides by 5 to separate the x from the coefficient there. And let's go ahead and get our solution. 65 divided by 5 is, again, 13. Okay, and if you plug that in, you would see that 13 times 5 plus 63, 13 times 5 plus 63 equals 128. Okay, all right, let's go ahead and try it out here. Okay, so the question is, what is x? How can you solve x? Well, I'd want to know, what are these two angles combined? Okay, notice it doesn't tell you anywhere. You have to know, oh, well, these are sitting on a straight line. Well, how many degrees is a straight line? If you remember back, a straight line is 180 degrees. So now go ahead and write your equation and solve it. Okay, pause, try it out on your own, and then let's see how you did. All right, so you should have 15x, or 15 plus 15x, equals 180. Separate your workspace, and we go ahead and solve. So subtract 15 on both sides, cross that out, and we have 15x equals 180, 170, 165, minus 15. Always double check anyway. And then go ahead and separate the 15 by dividing both sides by 15, and we end up with an x that equals 165 divided by 15 is 11. Okay, and there we go. So that's what x equals in that image. All right, let's go ahead and go to your apply. We're going to continue using this understanding. So Tamika is using lines and angles to create abstract art. She needs to find the measure of angle A. So right away, I'm going to make some little notes with some arcs here. So we want to find angle A. So I did this little arc here. To continue the pattern, what is the measure of angle A? So I love the thinking that they have us doing here. Okay, so you're going to use all of your information. One of the things that it's a little hard to see is, this is 90, okay? So now you start figuring out some things that you know or don't know. So there's a couple, what's cool is there's a couple ways we can do this. Like some things I see is, I see the x here, right? So I know 42 is equal to b, so maybe that would help me. I also know that 42 is here. I know that this is 90, and so I can also sort of figure out what A is from that way. So we have a couple ways of solving this problem, right? So let's do it a couple ways here. So first of all, if this is 90, okay, then this also has to be 90, okay, because it's sitting on a straight line, and 90 plus 90 is 180, okay? And so if this is 42, let me clean this up a little bit here. Okay, so here's my 42. So I know that this is 42 degrees also, okay? And if this is 42, okay, I know this whole thing, okay, is 90 degrees. This entire angle here is 90 degrees. So I could sort of say, well, let's call this x, 42 plus x equals 90. Okay, and we know that's the same thing as doing 90 minus 42, which you can see it plays out that way. And we have x equals 90 minus 42 is 48 degrees. Okay, and so A is 48 degrees. I guess instead of X, I could have called it A, but there's that method. Let's try it the other way and see that there's multiple ways of solving things. And so you may have wanted to do it that way. I see a straight line here. So I know this whole thing is 180 degrees. Okay, I also see this little box here that says this is 90 degrees. And so the other thing I know to be true then is 42 plus 90, okay, plus x equals 180 degrees, okay? And so we can go ahead and solve this. But before I start moving stuff around, I have some like terms, right? The 42 and the 90. So we can go ahead and combine those. They're like terms. So we have 42 plus 90. Okay, and that's 132 already. So we have 132 plus x equals 180. Okay, how do I get the x by itself? Well, let's subtract 132 to both sides, and we end up with x equals, let's see, 180 minus 132, ta-da, 48. Same answer, two different ways, which is what I love about this kind of math. All right, here's your check. I want you to go ahead and play around with this, and then you can continue and see how you did. So while playing racquetball, Tia bounced the ball off the wall at the angle shown. Determine the measure of angle A. So we want to find the actual degree, not just what is x. So understand that. We want to find what is the entire angle. So you're going to have to solve for x and then plug it in to see what that angle actually is. So be aware of what the question's asking you. So either way, what do you know is true about a straight line? Because I definitely see a straight line here. Well, we should know that this is 180 degrees, right? So if we add up all those angles, they have to equal 180, okay? So let's go ahead and create our equation, okay? Now remember that those parentheses are just organizational, and because we're adding, okay, we can move things around, any order, all that kind of stuff when you have addition symbols in between. Okay, so right away you can get rid of all the parentheses. So we have 4x minus 19 plus 58 plus 3x plus 1, and all of those angles equal 180 degrees. So first question is, we should probably simplify this, right? Do we have any like terms? Well, yeah, we absolutely do. Let's separate our workspace and let's highlight our like terms. So here's my X club. I have some more X club. And then I also have my constants. Okay, so let's go ahead and combine these and take care of that. I'm going to pull out the trusty old basic calculator here just because it's easier for my chubby fingers. All right, so 4x and 3x, 4, 5, 6, 7. So I'm good with that being 7x. So we have 7x. And then let's go ahead and add up all of our constants. So we have a negative 19 and 58. So it's 58 minus 19 is 39. And then we have a plus 1, which is 40. So plus 40 equals 180. So there we go. That's simplifying, remember? Distributing if you need to, combine like terms. So now we can go ahead and start getting the variable by itself. Subtract 40 on both sides, opposite order of operations. So we now have 140 equals 7x. And let's get that x by itself. Divide both sides by 7 and cross it out. And we have x equals, well, 7 times 2 is 14. So that's a hint of what the answer is going to be. 140 divided by 7, and we have 20. Okay. All right. So now that's just what x is. They want the entire a. Okay. So this is what a is. So if a is 3x plus 1, let's go ahead and plug in 20 to x. So 20 times 3, 2, 4, 6 is 60, plus 1 is 61. So angle A is 61 degrees. Okay, just to make sure that we're good, I'm going to plug 20 into X up here too. So we have, it's probably actually right at 20. So we have 80 minus 19. So 80, 70, 60. So we have 61. 80 minus 19. 80 minus 19. Yep, 61. So let's sort of see what we have here. So I have, let's see, I'll use orange. So we have 61 degrees here. We have 58 degrees here, and we said that we have 61 degrees here. Okay, and all that should add up to 180. So 61 plus 61 plus 58 is 180. So we are correct. All right, let's head to your homework. For your practice, you're going to go ahead and just do what we did in the notes, okay? Remember that angles are written with a flat line segment and then the angle up. So when you're naming the angle in 4 ways, okay, start on one side, you have angle H, F, G, and then go ahead and continue and list the other ways, okay? Remember my hints for vertical, okay, are to draw the X's to look at it if you don't see that as easily, okay? Be aware that we are, for number 3, it says identify 3 pairs of vertical, okay, and name all the angles that are adjacent to 10. So you're going to have to remind yourself what vertical angles are and what adjacent angles are, okay? Same thing over here, okay? So identify 3 pairs of vertical and then name all the angles adjacent to angle 3. So we're taking care of vertical and adjacent in one problem, okay? 5, 6, 7, and 8 are going to be you writing equations to solve for X, okay? And so look back at the examples if you need help with that, but I do want you to tackle all these on your own. All right, good luck and have fun solving the puzzles.